Mi amo, te amo, mi amo, yo, ay. Zion and Minamo, Jabingi is the motto. The bass gon' puff you up, you like it tough, then arigato. Bubba bouncing, always indie. So bump me in your Benzy, bump me in your Benzy, till your head stop feeling.
Okay guys, how's it going? And welcome to just one more Linux. Today we're going to be doing Packet Tracer Lab 1.5.5, which is found in Chapter 5. It is actually the first Packet Tracer Lab that you will come across in this course, Introduction to Networks. It is a very simple lab. If you wanted to download it, you would find it right here in Netacad 1.5.5, and you'd click right here to download it. You can view the outline of it right here. And it's also available in the lab. I'm not going to download it because I already have. So we're just going to go and open it in Packet Tracer. We're going to start by clicking File. And then I'm going to go to Recent Files because it's the last one I opened as well. Or no, it's not. Is it? No, it's not. We're going to go to... I'm going to go to Open. I think I might have it in my downloads. Where... is this it? I'm not sure. I thought it was 1.5.5. Maybe I'm wrong. I am wrong. It's actually... Okay. Let's take a second look there. Maybe I misread that. Alright. It's in section 1.5.5. But for some reason, it is actually 1.5.7. And I don't know why. Alright. So... the first thing you're going to notice when you open a Packet Tracer file, if you've never done so before, is you get this pop-up right here. This can be kind of annoying to leave it like this. I'm sure there are people who like to do that and keep it separate. What I do right here is on the bottom, you see this little box that says Doc right by the Check Results button. You're going to click Doc, and that will pin it to your window, and it'll stay there for the remainder of the lab. All right. Now, this lab is very simple. It actually looks really complicated when you first open it, although I guess if you've never seen a lot of Packet Tracer files, this may look normal. Most Packet Tracer labs don't have this many devices. Normally, it's a network, a very small network built to do a very specific task, and there's no excess, right? Just the stuff you need to complete or configure that certain thing. This is far bigger than most labs you will do, but we're not doing anything with any of it. It's here for us to look at. If you want to, you can explore it, and there's a few questions to answer. But beyond that, there actually is literally not a single command required to be entered or anything like that in this lab. You can even see check results is locked. Which they didn't even do that in the inaugural how to use Packet Tracer lab. They still had some things to be answered. All right, so without further ado, let's get into it. We'll read the objective. The network model in this activity incorporates many of the technologies that you will master in your CCNA studies. It represents a simplified version of how a small to medium-sized business network might look. Feel free to explore the network on your own. When you are ready, proceed through the following steps and answer the questions. Note: it is important that you understand. It is not important that you understand everything you see and do in this activity. Feel free to explore the network on your own. If you wish to proceed more systematically, follow the steps below, which is what we're going to be doing as I'm doing a walkthrough of this lab, which honestly really doesn't make much sense based on the nature of it, but I'm going to do it just because I want to have a complete library of labs from this course, right? So we'll go through some of these questions, we'll look around a little bit, Really, the best what to get what is intended out of this lab. If you are doing this, I would recommend just downloading the file, clicking on devices, checking them out, looking through stuff like the CLI, different settings. What does all this do? What does config do? What does services do? Just clicking through everything and checking it out. Without further ado, let's keep going on here. Step 1, identify common components of a network. Because I'm just going to go through this. There's not really much else I can do in this lab besides just go through it and answer some of the questions. The icon toolbar at the bottom left corner has various categories of networking components. You should see categories that correspond to intermediary devices, end devices, and media. The connections category represents the networking media supported by a packet tracer. There's also an end device category and 2 categories specific to packet tracer: custom-made devices and multi-user connections. All right, so let's zoom in on the toolbar down here. All right, the first thing, like it said, network devices. Then we have end devices. Then we have our components. Then we have connections or media. We have miscellaneous file, and then we have this multi-user connection thing, which I actually, and this is probably bad to say when I'm giving a tutorial, I have no idea what this does. I've never used it in any lab. I'm not exactly sure what you do with it. By the name, I'm guessing it's some sort of way to work on a packet tracer file together with a second person, but I'm not sure. First, we're going to go back to network devices, okay? And as you click on these devices, you'll notice on the bottom a sub-menu opens. So we click on network devices, and then we have this sub-menu on the bottom. Here we have routers, we have switches, we have hubs, which are no longer used, and I think you use them maybe in one lab to show you why we don't use hubs anymore, which I'm not going to rob you of that experience. We'll talk about it when it comes. Then we have wireless devices, security, right? And then WAN emulation. And these things are used right here to emulate wide area networks. You can see an example of it right here. All right, actually, you can't see that. Sorry. Hold on, let me click back. You can see an example of that emulation right here in the center. All right. Let's go back to the toolbar. So the next thing you're going to have is you're going to have end devices. There's a lot of different things in here. As you can see, you have your PCs, laptops, servers, network controllers, printers, IP phones. Then if you click home, all the rest of these are basically smart devices. You have all smart home devices here, like lamps, Bluetooth speakers, batteries, different things. Smart city devices, again, all different devices you would find around like a modern city. Industrial, same thing, just more having to do with an industrial facility. And then you also have power grid, which I'm not exactly sure. You have a blower, I guess that would be a fan, power meter, solar panel, all sorts of stuff. All right. Then you have this section, which honestly looks like you can do some pretty awesome stuff with. I've never done it. You have MCU board, SBC board, and then this one just called Thing. Actuators, sensors. All right. It honestly looks like you can do some pretty cool stuff with these little boards. I've never done it. I've always kind of wanted to look more into it and never got the chance. Then right here you have connections, which is pretty important. You're going to need to use this menu a lot to cable all your switches and routers and end devices together. Right here you have something that's called automatically choose connection type, and that will automatically choose the connection type for you. It's literally what it says. Then you have the console cable. You're going to have copper straight through, copper crossover, fiber, phone, coaxial, serial DTE, octal, IoT custom cable, and there's one more on the end that you can't see. It's purple. That's USB. To be honest, you're not going to use probably half of these, at least in this course. Most of the time, you're going to be using copper straight through. Occasionally, you'll use, well, not occasionally, you'll use console cables on a fair amount of labs as well. And then occasionally, for real, you'll use serial and coaxial. I think I've been required to use crossover a couple times as well, but I would say 90% of the time you're using either copper straight through or console. All right, so that's that. That's the toolbar really. Again, you have all your end devices right here, and most of the devices you'll probably be placing are going to be routers, switches, stuff like that, and then you'll connect end devices to the switches. Let's go back to this view and I'll show you what that looks like to add a device. So right now we're clicked on network devices. We have routers. We're going to pull this router out, place it right there. Then we get a switch, take it and place it right there. And then to cable it, you just go here, click copper straight through. When you click it, a drop down menu pops up and you can select what interface on the device you want to connect to. Okay? And that's it. And that's how you connect any device. You know, say you want to connect an end device to the switch now. Okay, so we take out a PC, drop it right there, get another cable, connect the cable to the switch, and then connect it to the PC. Okay, and all the cabling and connections work the same way. That's how you do it, and that's how you build networks in Packet Tracer. All right, for now we're going to delete this. All right. And then we're going to get back into this here and answer some of these questions. All right, the first question here. List the intermediary device categories. All right, well, we just did that. We have routers, switches, hubs, wireless devices, security, and WAN emulation. Without entering into the cloud or internet cloud, how many icons in the topology represent endpoint devices? Only one connection leading to them. All right, so endpoint devices are going to be PC, your IP phone, guest, laptop here, smartphone, tablet, home laptop, inkjet printers. Those are all end devices. Without counting the two clouds, how many icons in the topology represent intermediary devices? We're not going to count them. It's boring. But our intermediary devices are going to be the routers, the switches, and this wireless access point right here and here. Or this is a wireless router, and this is a wireless access point right here. All those are intermediary devices. So routers, switches, the access points, intermediary. All right. Let's go on to the next one here. How many end devices are not desktop computers? Now, if you want to pause the video and count this on your own, feel free. I'm just going to list them really quick. We have a home laptop, a tablet, a smartphone. We have inkjet printers, a laser printer. We have servers. That seems to be about it. Oh, we have the phones as well. How many different types of media connections are used in this network topology? Right off the jump, you can see, without really having to do much work, that there's 4. We have Ethernet, we have the serial, we have coaxial, and we have wireless. Part 2. Explain the purpose of the devices. In Packet Tracer, only the server PT device can act as a server. Desktop or laptop PCs cannot act as a server. Based on your study so far, explain the client-server model. All right, so breaking it down in a simple form, a server is going to host something, and then the computer is going to access it, right? Whether it be a website or something else, a file. The server will host it, and then the end device, or like the computer, is going to access that content. All right. B, list at least 2 functions of intermediary devices. Okay. What are 2 functions of intermediary devices? Let's look. We have our wireless access point. This is allowing end devices to connect wirelessly to our network. A switch What's a function of a switch? A switch can be used to create VLANs on the network. What about a router? A router routes all the traffic across the network, right? Um, Simple enough, right? Let's see here. What's the next one? List at least 2 criteria for choosing a network media type. I'm going to list what I consider to be the most important ones. They're going to be cost and speed, right? Now, I don't know how often you're going to see this in something like an office setting, as office settings generally pay very close attention to the cost of building their network and try to go for the cheapest routes possible. But in a home setting, you often find people far surpassing their needs and going for just like the best option they can get, even if it's not really needed, right? An example of this is gigabit Ethernet. I had gigabit for a long time at my house, right? A lot of people have it. And it's not cheap, it's very fast, but it's not cheap. And I loved it for a long time. I was really excited about it. I could download games super fast. My internet was always fast. It was a very strong connection, right? The thing is, beyond downloading game files, I didn't really download many large files that often. And beyond that, there wasn't really much I did that required gigabit Ethernet speed. And even downloading games, it's not really like I was in some hurry to download the game. Difference of like 250 to gigabit, I could just start downloading it while I'm at work and then come home and play it. It'd be done by then, instead of having it in 1 minute at the last minute. I ended up getting into some budgeting issues and was pretty broke for a while and switched to 250 megabit internet. I was really worried at first and was like super upset that I had to do it because I loved having really fast internet. But what ended up actually happening was I found out that it actually had almost no effect on my life whatsoever switching to 250. My connection is still great. I generally have a very consistent 250 up. 250 down. My up is normally not that great, but it wasn't that great with gigabit either. So the only difference that I really noticed was, again, downloading like large game files. And the way I found around that was when I bought a new game, I would just start downloading it while I was out at work or something. And then by the time I came home, it would be done for sure every time. It didn't even take that long anyway still with 250. Especially most of the games I play, it didn't take that long. And on the off chance that I wasn't at work, I would just wait. And that's the only difference I noticed. Beyond that, when it comes to surfing the web, watching videos, watching movies, literally no difference for me. Not that I could tell. I'm sure there is a slight difference in how fast the web page loads, but it's nothing that I'm going to actually be able to perceive, right? So I would say, after going that little tangent there, right, the biggest thing you want to consider when choosing a network media, and again, speed does not necessarily have to do with network media. It does to an extent, right? Because the media has to be able to transport the data at that speed. But I would say, what speed are you using and the cost, right? For instance, like setting up fiber is going to cost way more than it's going to cost to use Ethernet cable. Do you need that? Do you really benefit that much more from using fiber? If so, then is it worth the cost? Then get it. If it's not, stick with Ethernet. All right. Step 3. Compare and contrast LANs and WANs. Explain the difference between a LAN and a WAN. Give examples of each. This one is very simple. We can see from looking at this right here, we have 3 different LANs. And I believe it asks this, right? Yeah, it does. And they're all connected by a WAN, right? A LAN is a local area network. So something like the office building next door or your home. Those are local area networks, right? And then the WAN is connecting many local area networks. In this packet tracer network, how many WANs do you see? We see one right there in the middle, connected by all the serial cables. How many LANs do you see? We see 3. 1, 2, 3. The internet in this packet tracer network is overly simplified and does not represent the structure and form of the real internet. Briefly describe the internet. Right? Well, the internet is, of course, the biggest WAN. It connects everybody across the world. It connects all of our local networks and allows us to communicate with each other and share information and data. What are some common ways a home user connects to the internet? Wireless. They connect through their routers, modems. I would say a lot of people these days are using wireless gateways and just connecting wirelessly. I personally don't do that. I have everything in my home hardlined in. What are some common methods that businesses use to connect to the internet in your area? A lot of businesses are probably going to be using fiber. And a lot of people don't realize this, but businesses also generally pay much more for internet. They have to get business class. It's a whole different thing. Challenge question. All right. I'm going to actually skip this part to let people figure it out on their own, because I think that's really the point of this lab is not that you walk through it but with someone else or that somebody helps you figure it out. I think it's to get you up to speed on where you are and what your knowledge level is, right? Where are you starting out? What do you know? It's kind of to get you to realize that, like, how familiar are you with this stuff already, right? I'll read off some of the questions, but again, I'm not going to go through these because I think that it's best when you're doing this to do it on your own. You're not necessarily supposed to be able to figure this stuff out, but if you can, that's good, and it shows you that you're a little bit further ahead. Walking somebody through that kind of ruins that discovery. So we'll still read them though. Add an end device to the topology and connect it to one of the LANs and immediate connection. What else does this device need to send data to other end users? Can you provide the information? Is there a way to verify that you correctly connected the device? All right. Add a new intermediary device to one of the networks and connect it to one of the LANs or WANs with immediate connection. What else does this device need to serve as an intermediary device to other devices on the network? Open a new instance in Packet Tracer. Create a new network with at least 2 LANs connected by a WAN. Connect all devices. Investigate the original Packet Tracer activity to see what else you might need to make your new network functional. Record your thoughts and save your Packet Tracer file. You may want to revisit your network later after you've mastered a few more skills. All right. I will do one thing. Again, I showed you how to add a device earlier, so anybody at this point should be able to try and do that on their own. See if you can figure out exactly how to get your device connected to the network. Take a device and connect it to S1 or S2, right? In fact, I'll do it just to show you how, but I'm not gonna give away actually getting it functioning, right? And it's not that complicated, to be honest. You can click here, right? Fast Ethernet, and then you're gonna connect it to an open port. Okay? Now, that's how you connect a device, and you can do the same thing with the intermediary device, just not in the same place, of course. Go on, test this stuff out, see how far you can get, right? I'm going to do something else right here just to remind you guys about simulation mode. And just because I'm curious how connected this is and if they have it set up properly, if it's actually all humming the way it's supposed to. Then again, we don't know exactly how they have this all set up. So let's see. This device up here is going to have, oh, geez. Okay. 192.168.0.101. Okay. Now we're going to follow this in simulation mode. Let's see if we can get there. And if we can't, I want you to answer in the comments why, right? So let's see first if it does. Probably should have separated the filters first before I did this. Got a lot of extra noise and stuff going on. It looks like this is actually not going to be able to reach this device. Let's go back to real time because we're bouncing back and forth there. All right, now it looks like we're completely unable to reach this device. Okay. I think I have a hunch as to why, but a little bit of homework here in the comments. Why don't you see if you can replicate this and send a ping to this address and tell me why we are unable to reach that device. Okay, what is the reason that we can't get there? All right. Is it something that's improperly configured? Do they have it configured so that we can't actually ping that device? What's the reason? And if you're unfamiliar with what a ping is, we'll do another one really quick so we can show you what a successful one would look like. All right, this is 10.3.0.4, and we are on PC 4, which is the same but 0.3. Okay, so we're gonna ping 10.3.0.4. And this is what a successful ping would look like. You get a reply. Now, sometimes the replies do fail, and they don't actually work right away. You'll have like 2 fail, and then you'll get the last 2. And that often does happen when you send out the first ping. Sometimes it does, sometimes it doesn't. But this is what a successful ping would look like, right? And if that does happen where the first 2 or 3 fail, and then you get a good one, you'll see that it says like 75% loss or 50% loss. And then after that, on the next one you send, it'll be completely successful. And then let's also break it down really quick, I guess, in simulation mode so you can see what it looks like. Here, let's set the filters this time. Probably should have done this last time. Let's go. We're on IPv4, so we're going to turn off all the filters except for ICMP, which is what ping uses. Oh wait, did I? Okay. Okay, so we're going to send that again. Okay. You see it move to the switch and then move over to the other PC. Okay? And we're completely able to communicate on this network. All right? And right here we see the green check mark, which means it was successful. All right? And you can click on it and you can break it down further, which obviously this is going to be way too in depth for you guys right now. But you can, if you want to, explore a little bit more, right? Now let's see over here, actually, we have a completely separate network, right? Same router, but can we communicate with PC1? Let's see. So what's the address for PC1? That's going to be 10.2.0.1, okay? So let's click real-time first just to finish that up. Okay, go back to simulation mode, and now we're going to do... Gosh, I already forgot it. My memory is not so great these days. 10.2.0.4. 10.2.0.4 is what we want to ping. I think I actually read the router, the gateway, the first time. Yeah, I think I said 0.1, which would actually I think is the default gateway for this network. Yeah. So anyways, this computer is 0.4, so we're going to ping that. Let's see how that looks. And let's see if we can reach that device. All right. I'm just going to click through a lot of these until we see a failure. Oh. So it looks... Let's see here. Oh, there we go. So we are able to reach this device. And if you want to go back and see... Oh, we're not going to go back through all that. We are able to successfully reach this device as well. okay? And that's what I was talking about. See, we have 25% loss. The first one missed. Now if we send the second one again, we can see that they all go through, and we have 0% loss. So we are able to reach that as well. So again, in the comments, why are we not able to reach across the simulated internet to ping another device over here? Let's do one more. Let's check out one of these devices. Let's see if we can reach one of these devices. .172.16.0.9. Is that right? Yep. Okay, let's see if we can get this one. Oh, let's try on simulation. All right, let's see what happens here. Now, are we gonna get stuck here again? It looks like we are. All right, I'm gonna go back to real time and let this play out. It looks like this one is gonna fail as well. So I have my hunch about why we're unable to reach the other networks. But you tell me in the comments, what is the reason? Why can we not reach these other networks, but we can ping stuff, not even necessarily on our own, but other subnets even. We're completely unable to reach these other 3 LANs though. Why? Why can't we? See if you can figure it out. All right? Yep, 100% loss, completely unable to reach it. So what is the reason for that? And also, just have fun playing around with this. Ping other devices. Figure out how they work. Try some other basic commands. Go click onto the router and go into the CLI and check out some basic Cisco commands. Look them up on, ChatGPT or Google. Have fun with it. Dig into it as much as you can. Figure out where you are in your networking knowledge before you get started here. What do you know? What do you not know? Anyways, thank you guys for watching. This has been just one more links.
I'm feeling lost in the crowd, and I don't wanna lose touch. Nah, like it's about to go down. Well, you can never get enough.
Now everything poppin' bars, put you right, mix the lane, get the Sprite, get the brain, get the pipe, get the chain.
Now everything
Poppin' bars, put you right, mix the lane, get the Sprite, get the brain, get the pipe, get the chain.
raise your hand, Texas sun, megaton phenomena. Here they come, drop the bomb, fire up another one. What it do? Thought you knew what the boom do to you. Crush the building with my crew. Meet me at the open zoo. I'm sitting on the sub, my bitch seeing dub. I'm whipping in my crab, burning rub in the gutter. I'm standing on the speakers, I'm busting on fofo. I'm getting deeper, deeper, deeper. I'm feeling lost in the crowd, and I don't wanna lose touch. Nah, like it's about to go down. Well, you can never get enough. Oh, no.
Everything poppin' bars, put you right, mix the lane, get the Sprite, get the brain, get the pipe, get the chain.
Now everything
Poppin' bars, put you right, mix the lane, get the Sprite, get the brain, get the pipe, get the chain. And I don't wanna lose touch.